Hi, in this video we are going to implement together the so-called Euler method and how to solve differential equations, and we are going to focusing on the harmonic oscillator if you are familiar with it. For example, if you want to close a door and it can turn out to the next side, it's going to do something like the harmonic oscillator, and the amplitude is going to decrease exponentially. We are going to see the plot and it will be clear. So I'm going to include IOStream, I'm going to include the Fstream because I want to create a CSV file. We are going to save the data, and later on we are going to plot with the help of this plot.ly because you can upload it to a server and it's going to plot it. You don't need any softwares. To be honest, I usually do it on Ubuntu Linux, and the GNU-plot software is very easy to handle and manage these kinds of problems. But anyway, so I'm going to use the standard namespace. I'm going to include the math.age, and I'm going to define some. We will have a method f. It's going to get a double x. We will have another f2, for example. It's going to get a coordinate and it's going to get a velocity. I'm going to have a double k, it's a constant, 0 to 5. I'm going to have a double v is equal to 0. I'm going to have a double t is equal to 0, 2. I'm going to have a double, this is the infinitesimal tiny step of time we want to make, and we want to add it to the on each iteration we add a little t dt time to the t. Okay, 0.1 for example, we will have a double x equal to 1, and we will have a double b. It's going to be the constant before the velocity, and it's going to moderate the friction. Okay, so in my main method we will have a, first of all I'm going to define the methods. For example, first of all we want to test whether our oscillator without friction working fine. We just have to return negative k times x, where k is a constant. It is negative because the force try to pull back the door or whatever we are simulating. And yeah, I'm going to have a IOStream data file, that open, for example, data.csv, and later on I'm going to data file.close, and I'm going to return 0, for example. So in the while cycle it's quite obvious. We just have to, while the t is less than 50, for example, we just have to increment the velocity with f with x times dt. We are going to simulate it with the help of Euler method, and we are going to, the f function is like this, so we have to multiply it with dt, a little time scale, and we just have to add x is equal to x plus v times dt. If you are familiar that v is equal to ds per dt, then the ds from this equation, the ds, where here is the x, so it's going to be x. The x is approximately equal to v, the x0 plus v times dt. We just have to rearrange this equation, so that's why it's written like this. We have to increment the time with a little time step, and we have to print it to the data file. So I'm going to print it like t. I'm going to print a comma separated file, because so I'm going to put a comma, an x, and of course an end line. So that's all. We are going to close it after the operation. So let's see. I'm going to print out to the console to see whether it's okay or not. X end line, and we can make an assumption whether our algorithm is working fine or not. Yeah, it's oscillating as I see. So here you just have to import the data like this, import the data, upload a file, and you have to select the .csv, and you have to specify the x and the x-axis, the y-axis. We have to specify that it's going to be a line plot, and we just have to create a plot. And yeah, that's what we are going to expect. I mean, that's what we expected, because there is no friction, and because there is no friction, the amplitude is the same in the function of time. So this is what we get. This is the solution of the harmonic oscillator, and see what result we get if we, for example, if we try to use the second method, f2 with x and v, and there's a friction. Oh, I haven't used it. Okay. So in this method we have a double f2 with double x and double v, where x is the coordinate and the v is the velocity. So we just have to return minus k times x, but we have a friction term, and with the scalar b times the v. If you are familiar with physics, this is exactly what frictions look like. It's going to be proportional to the velocity of a given object. For example, yeah, the greater the velocity of an object, the greater will be the friction. So if we run again with our CSV, I think, yeah, it's going to be exponentially decreasing the amplitude. So I'm going to import it again, I guess. Okay. Loading a file may be a bit longer, but anyways, I just have to select the x-axis, the y-axis, line plot, and have to plot it. And the solution for this differential equation, as you can see, very nice. The amplitude is going to decrease exponentially. We could fit an exponentially decreasing function to the top of these amplitudes. So the amplitude itself is never going to be exactly 0. It's going to tend to 0. So that's all about the Euler method and simulating friction and non-friction harmonic oscillator. In the next video we are going to see how to solve these kinds of problems with the help of the much more precise Runge-Kutta method. Thanks.